Hello, hello. Welcome to my channel. In this video, we are going to solve one J main problem. A particle of mass m is moving in a circular path of constant radius r such that its centripetal acceleration is varying with time t as a equal to k square r t square, where k is constant. The power delivered to the particle by the force acting on it is given by. So options are given. Okay, we have to find out what is the power delivered, okay, to the particle by the force acting on it. Okay, now let us solve this problem. Okay, so we already know that, okay, in circular motion, okay, two forces acts. Okay, one force always directed towards the center, and that force is called centripetal force, and one force is always directed towards the tangent of the circle or tangent of the circular motion. We call it tangential force. Okay. Now, what is this tangential force? Tangential force is nothing but mass times, okay, tangential acceleration. Okay. And mass times we can write tangential acceleration as dv upon dt. Similarly, what is Fc? Fc is nothing but centripetal force. Okay. This is centripetal force, and we write centripetal force as mv square by r. Now, can you tell me which force is acting, which force is doing some work or doing or delivering power, okay, to the particle? Okay, so you can see here this force, that centripetal force, okay, centripetal force is always responsible for the change in direction. Okay, so this force always changes the direction of the particle. Okay, so responsible for the change in direction, change in direction. Okay, and this force is responsible for the change in speed. Okay, so this force is responsible, okay, for change in speed. Okay, so here you can see that, okay, this force, the centripetal force, is always directed towards the center. Okay, now this particle is moving tangent to the direction of the particle is always tangent to the circular path. That means if the particle is here, okay, it is always directed towards the, okay, tangent of the circle. Okay, now the displacement is always happening perpendicular to the centripetal force. Okay, that means the work done or the power, what is the formula of power? Power is given by force dot displacement. That means there are two forces acting. One force is centripetal force and one force is a tangential force. But this centripetal force is not doing any work. Why? Because because you can see here the magnitude of centripetal force and the magnitude of this velocity and the angle between them is 90 degrees. Because you can see here the displacement is always perpendicular to the direction of centripetal force. That means we can write the power delivered by the centripetal force is always, okay, is always equal to 0 because cos 90 is equal to 0. Okay, but here one force is acting, that is centripetal, that is tangential force. Okay, and the direction of the displacement is always along the direction of the tangential force. So power is only delivered by the this tangential force. So power delivered by the tangential force is given by the force, okay, multiplied with the velocity. Okay, can we write this one as Ft? Okay, V, the magnitude of the tangential uh, force and the magnitude of velocity and the angle between them. What is the angle between them? That is 0 degree because you can see here displacement and the velocity is also in the same direction and the tangential force is also in the same direction. So we can write power as Ft V cos 0 degree. So cos 0 degree is 1. So we can write Ft V. Okay. Now what is the formula? So what is Ft? Ft is nothing but m times dv upon dt. So we have to calculate what is the v. Once we get the v, then we can differentiate this. and put it here to get the final result. Okay, so how to calculate v? So in the question it is already given, acceleration is given by the centripetal acceleration is varying with the time t as a equal to k square r t square. So a is equal to centripetal acceleration is given by k square r t square. But we already know that this centripetal force can be written as m a c. What is AC? That is centripetal acceleration. That is given by, once you compare it, you can see that AC is nothing but v square by r. Okay, this is k square r t square. So can we write v square is equal to this v square equal to k square r square t square, and that we can write as v is equal to krt. Okay, now we know this power delivered by the tangential force is given by m dv upon dt, and then again multiplied with a v. Now we have to find this dv upon dt. So what is dv upon dt? Dv upon dt is given as differentiation of this velocity. Okay, so what is the differentiation of this velocity? That is krt. So we can write k is constant, r is constant, and t is variable, so we can write kr. That is the differentiation. Okay, so we have to substitute all these value, the dv upon dt, that is kr, and the velocity v is also known, that is krt. We have to substitute this value here to get the power delivered by the tangential force. So that is given by m. Okay, and dv upon dt is kr, and then multiplied with the krt. So what is the final result? That is m k square r square t. M k square r square t. That is only the power delivered by the tangential force, not the centripetal force, because centripetal force is always perpendicular to the displacement of the particle. Okay, so this is the final answer, mk square r square t. So mk square r square t, that means this third option is the correct option. Okay, thank you so much.